Okay. Welcome everyone to our last spring webinar in our series on using Facebook as a research tool. We're very excited to have Ingmar Weber here to share his experience of working with various platforms, not just Facebook, in using it for research, and in particular zooming in on using audience estimates that we get when we run advertisement as part of our research. As always, Ingmar, you will have about 40-45 minutes to tell us about your experience and share your wisdom with the group here. And in the meantime, we will collect questions. So please, in the audience, if you have questions, use the Q&A button rather than the chat. It's easier for us to manage this. And then at the end, we will have some time to go through these questions and have also a bit more general discussion. So with no further ado, over to you, Ingmar.
Great, yeah, thank you very much, Anja, for the introduction. Also, thanks, ICOT, for setting this up and for inviting me. Yeah, so I'll talk about sort of how do you can use sort of passive data in a sense, right? Not actually launching ads, but sort of what you can sort of get before launching an ad. And so what I'll be presenting is a joint work with a number of other people. So here at my institute, so the Sakata Computing Research Institute, we have my colleagues Joao and Masumali, who have contributed quite a bit. Then at the University of Oxford, there's my collaborator Ricky Kashyap. And then there are a number of other people who have sort of contributed to this line of work over the last 5, if not even 6 years now, including people at UN agencies and NGOs. Right, so if you're part of this webinar, I'm sure you've heard this sort of slogan before, right? If you're not paying for the product, then you are the product, right? And obviously you're aware that Facebook collects a lot of information about you if you're a user, right? So this is then used to build up profiles that can then be used for targeting ads, right? As we've sort of also seen in the other sort of sessions, right? And so, for example, you can very selectively launch an ad only to female Facebook users living in London, age 25 to 29, who lived in Poland and to use an iOS device, for example, right? And that might be useful for sort of targeted surveys, for example, right? As I think was discussed also in other sessions. But now the crucial thing is that before you launch your advertising campaign, Facebook already provides you with so-called audience estimates, right? Because it matters, when you want to plan your campaign, are there 1,000 matching users or 100,000 or 1 million sort of a site? I mean, you need to know roughly how many people, you could expect to reach, right? Because that is sort of budget implications, right? And so in this particular example, Facebook would tell you upfront, right? So before you launch your advertising campaign and before you have to pay anything, that there are 2,600 monthly active users matching these particular criteria, right? And so if you think about it, that gives you a no-cost real-time census over the, just about sort of 3 billion Facebook users, right? Where you can sort of issue account queries, right? Like how many Facebook users match certain criteria, and then sort of Facebook comes back and tells you the answer, right? And so then the question is that, I talk about, so how can we use such data for research? I actually want to make this very concrete and show you the platform live. So this is always the most dangerous part, right? Like a live demo, but let's give it a try. So now you should be able to see Facebook's advertising platform, right? Where at the moment I've selected Facebook users living in a particular location, and this location is Norte de Santander, which is part of the country of Colombia. I just zoom out a bit. So we have sort of Venezuela on the right in the east, and then you have sort of the country of Colombia in the west. I've selected all Facebook users aged 18 and above, all genders, everything else, all. And I've also selected only, or actually, let me just change this to have only Facebook users, itself, not including Instagram or sort of other platforms. And at this stage, you can see here on the right that Facebook shows this audience size estimate, right? There are about 1 million to 1.2 million matching my criteria, right? So now what can you do with it? Well, you can sort of play with these additional sort of targeting criteria, right? So for example, in some of our work, we look at people with a migration background. So I can now only look at Facebook users who lived in Venezuela. And then again, before I launch my advertising campaign, Facebook already tells me how many people match this targeting criteria, right? And sort of, so this is, I mean, this is because we realize actually in this particular location is quite a big percentage, right? So well over sort of 10% of all Facebook users who are currently living in this part of Colombia used to live in Venezuela. I don't know if you can be sort of more specific. I mean, you can sort of combine this with limiting the gender, or you can also further limit this to device types. So you can sort of look at, for example, how many of these users are using iOS devices, because typically speaking, iOS devices are more expensive, right, et cetera, right? Sort of, so, and again, you get all of these estimates for free before launching the actual advertising campaign, right? Okay, so that's all jolly good. So what can you do with this? So I'll show you a couple of data visualizations just to give you like a sense of what you can do with this type of data. So here I'm showing you a visualization we've created around data that was collected about 5 years ago, right? So in this case, it's for the city of New York. I suppose you didn't know anything at all about this city and you wanted to understand wealth distribution. Then, you know, in this data visualization, you can sort of look at what is the spatial distribution of iOS users among Facebook users, right? So here you would see that in sort of lower Manhattan and Midtown, so sort of the banking district, right? You have about 90% of Facebook users using iOS devices, right, which are typically more expensive than Android devices. On the other hand, in sort of in the Bronx, you only have sort of 40 to 50% of Facebook users using iOS devices, right? So you can sort of like, you know, you rightly expect this wealth differential between those two areas, right? Or you can look at people with a migration background and sort of look at where's the density highest of people who used to live in Latin America. And again, you sort of see here in sort of parts of the Bronx and neighboring areas that about 40% of Facebook users, you know, in the past I used to live in a Latin American country, right? And so this was again sort of tell you something about the likely demographic makeup in this location. Again, in this particular case, of course, you have census data and other data sources, so you could discover the same things through other and probably more accurate data sources. But in other locations, you don't necessarily have the same sort of open government data available. And this includes the city of Doha that I'm currently in, right? So here's sort of the same thing. So we collected. This is not live data. This data was collected about sort of 5 years ago, right? Where we would sort of query an API that I'll show you in a second. About how many Facebook users are in this part of Doha who male with a university degree in a particular age range, from a particular country, with a particular device type, right? So all of this was sort of collected beforehand. Once you have collected this data, you can, for example, look at say people who lived in Nepal. The density is highest in the industrial area, which living here, I can tell you, is true. But again, you don't have, sort of official data on this, right? So they are almost all men, fairly young, which is a blessing during COVID times, right? Because probably the vast majority of them were infected with COVID at some stage, but only very few fatalities because they are fairly young, and they're almost all Android device users, right? And you can sort of contrast this with people from other backgrounds, such as from Western Europe and North America. So right now I'm at home. I'm here, not sort of coincidentally. I'm here with my wife, so there's a gender balance. I can bring over my wife, and family here. So for that you have to make a certain minimum income to get a family visa. I'm a university graduate. I'm still in this age range, right? But they're sort of approaching this age range, right? So typical, let's say, knowledge experts. And you have actually more iOS device users than Android device users, right? And so again, this will sort of tell you that it's probably a very, very different experience of life, right? Between the sort of Nepalese and, in my case, sort of Germans. And again, conceptually, you can sort of collect such data anywhere in the world. I should give you one last example. This is now the city of Lagos, where, again, you can sort of do the same sort of things, right? If you want to understand the wealth distribution, you can, for example, as a first order, you can look at the density of iOS devices, and you'd see that here in this part of Lagos, this is Lagos Island, you have about sort of 15% of Facebook users using iOS devices, and this is also where the government is located, right? So that makes sort of sense. When the rest of Lagos, it drops from 15% to maybe 7%. Then the outskirts, it drops sort of further to sort of 4 or 5%, right? And so you would probably assume, right, and most likely correctly so, that sort of there's more wealth here, and then slightly less here, and then even less there. Now, this data was not collected by sort of, screen scraping or writing down numbers, but through an API, right? So you make an sort of HTTP GET request. So there's a very simple API, and this is sort of what the data looks like. That's returned, right? It's a bunch of JSON. So let's look at it in a sort of slightly more readable sort of format. Let me close some of this, right? So there's a bunch of things that are being returned. I'll talk about those in a second. But the most important thing is that you get these things up here, right? So you have the estimate of MAU. This is the monthly active users. That includes an upper bound and a lower bound, as well as the estimate of DAU. This is called daily active users. In this case, this is for women in the US. Then you also get this outcomes curves by day, and something we have not yet analyzed, but I think that might actually be quite interesting to look at, because in a nutshell, it tells you how much you have to bid and spend to reach a certain number of people, right? Or put differently, it tells you something about whose eyeballs are most expensive, right? Like sort of, right? So for example, typically, of course, there's a location element to this, right? I mean, like running any ad in Manhattan or so will be very, expensive, or more expensive than, in different part of the US. But you could even look at sort of, demographic differentials, right? Maybe, I don't know, the eyeballs of old white men, so to speak, right, are more expensive than other groups, right? And you could sort of look at it from maybe a discrimination perspective or so, right? And so anyway, so we have not yet analyzed this data, but just to mention that this is also part of what the API returns. If you don't want to, sort of talk to the low-level API yourself, there's also sort of wrapper APIs that a colleague of mine has sort of created and worked with a World Bank to sort of document. And I'll make sure to share those resources, but just to mention so they're nicely, very easy to use sort of wrapper APIs on top to sort of facilitate collecting such data. Also, just a quick side note that while this is about Facebook, and I won't talk about Facebook during this call. You can get similar data from LinkedIn, Snapchat, Twitter, and other platforms. I'm happy to talk about our experience with other platforms in the Q&A later. And then the last thing, just to hear, so to give you a sense of what it looks like, what you would have to provide. Essentially, you have to provide a bit of sort of JSON where you specify the data you want to collect, right? In this case, for these two countries and for sort of different genders and sort of for a particular age range. And then you sort of, you launch it, and then it sort of, later, returns sort of like a data frame with sort of different sort of counts, for what you specified. Okay, so let me go back to the presentation. So I showed this. Okay, so just to elaborate a bit more on the criteria you can use for targeting, and also sort of to contrast it with LinkedIn, sort of to show you if that's of interest. So some attributes are self-declared, right? So on Facebook, for example, age and gender would be self-declared. On LinkedIn, your employment history is self-declared, right? But that also includes things such as your sort of hometown, your education level, and also your friends, right? Or your sort of your contacts on and skills on LinkedIn. Then you have certain things that are metadata, right? For example, like the device type, right? I showed you something about sort of Android and iOS before, right? You don't explicitly declare. This is sort of, metadata based on how you connect to the platform, right? Similarly, you would not explicitly declare your current location, but that's inferred either from your GPS if that's enabled, or from your IP address, or from the Wi-Fi you connect to, etc. And similarly, your connection type is also used by LinkedIn, as well as whether you're sort of frequent traveler. And then there are other things that are inferred, right? So, for example, Facebook somehow infers your home country, right? Like, or countries you have lived in, right? And we can sort of speculate how exactly that's done, but ultimately it's a sort of black box inference algorithm, right? Similarly, sort of things that you're interested in, right? I mean, sort of many things that you like on the platform, but also things that you do on other websites, through sort of cookie sharing, are sort of inferred, right? In the case of LinkedIn, even basic things such as age and gender need to be inferred, because you never actually explicitly specify those, but still you can use those for targeting ads later, right? And so so basically the interest is now where maybe the murkiest things come in, right? So when you have all this sort of, cookie sharing and inter-app sort of sharing of data. Typically, that relates to sort of the interests on Facebook, right? And so these are also now things that would most likely be affected by, for example, privacy changes in iOS, etc. So this is where where you'd see the difference enter in your analysis. I'll also share these links, or they're part of the slide deck that I will share, where you can sort of access your own data, right? And I think it's a good exercise sort of to do, right? Just to get a sense of how much Facebook knows about you, but also often how much noise there is in the data, right? So a lot of things that you might go, oh wow, that's really like, how do they know this? And then there are other things that, oh, why would they think that sort of, right? I mean, I sort of want to say that everything is sort of perfect and everything, but it's interesting sort of to look at your own data to understand the data quality issues. So now the rest of my talk, I talk more about sort of applications, right? So okay, so now you can collect such data, but now what do you do with this, right? So in my own case, most of my work relates to international development, right? So we try to use such data to fill data gaps in this space, right? And so what kind of data gaps exist? So often data on development indicators is slow, right? So often it's linked to sort of census data that's only collected once every 10 years. It's often spatially very coarse. For example, you might have one data point for the state of Uttar Pradesh in India, but that has 200 million people, right? Or what does it mean if you have one data point for 200 million people, right? It doesn't tell you much. Or it lacks disaggregation along demographic attributes, right? So maybe you're interested in understanding poverty from a gender dimension, right? So if only the male head of household has access to wealth and assets, then maybe that's, you want to know this, right? So how can you have something that's gender disaggregated, right? So in a nutshell, where advertising data in particular from Facebook is useful is for improving the recency, right? So if you sort of collect data regularly, you can sort of look at changes in time, and I have some examples on that later. Also in terms of sort of spatial resolution, right? You can sort of look at sort of subnational variation, and I have examples of that. And then last but not least, but also in terms of sort of having demographically disaggregated indicators, for example, related to poverty. So yeah, rest of the talk will just look at sort of 3 examples, one related to international migration, one related to mapping poverty, and one looking at digital gender gaps. Okay, time, okay, yeah. So the first example I'll talk about is a joint work that we did with UNHCR, UNICEF, and an NGO called IMAP on monitoring the Venezuelan exodus. So just in case you're not familiar with the sort of the background, so in 2019, which was more or less when we sort of did this work, the annual inflation in Venezuela was 10 million%, according to the International Monetary Fund, right? So it's not a typo, it's really 10 million%, right? So it's sort of hyperinflation. Unemployment upwards of 40%. If you were earning minimum wage and you paid every single, I believe it's peso, on food, you could only afford 1,000 calories per day, right? So this, I mean, you're starving, right? So this is a so-called Maduro diet. So in, as a result of this, many people have left Venezuela, sort of so upwards of at least sort of 15% of the population, mostly into sort of neighboring countries and a bit further away. Now, how many people exactly, and where exactly? Well, that's not exactly clear. So I think now, over time, data is getting better, but especially, while the exodus was sort of happening, the data was not very good. So so we try to address this through collecting these audience estimates from Facebook. So let me try to explain what you sort of see here. So all the data that you see relates to Facebook users who lived in Venezuela, right? So that's sort of what I showed before. It's sort of disaggregated by different host countries. So let's look at only the data in red first. So that's the host country of Colombia. So this data point down here, for example, was collected in June 2018, right? So in June 2018, there were about 1 million Facebook users who at that time were living in Colombia, but according to Facebook, had previously lived in Venezuela. Okay, so this is this estimate. Now, if we assume that there are no false positives in the set, right? So if we assume that every single one of those is a sort of migrant from Venezuela, And if we assume that not everybody is on Facebook, so then this is of course a lower bound, right? That's sort of just lower estimate, right? And so we would like to correct for the fact that not everybody is on Facebook. So for that, we would have to know the Facebook penetration among migrants from Venezuela living in Colombia. That we don't know, but we now make the assumption that the penetration is the same as among all people in Colombia, right? So we look at what's the total population of Colombia, what's the total number of Facebook users. Let's say it's 60% Facebook penetration. So we're now adding the missing sort of 40% on top, right? And so this would then give us this estimate of the total number of Venezuelan migrants who at that point were living in Colombia, right? And then we sort of collect this data, across different locations and sort of, over time. So now, how good are these estimates? Well, so here in black, I'm highlighting estimates from different UN reports for all of Latin America, right? So this now you have to compare against this sort of these sort of gray bars, which is sort of data for all of Latin America in aggregate. And you can sort of see sort of at least similar order of magnitude, but probably data from Facebook would suggest that there are probably more migrants. Certainly, if you sort of the sort of upper estimates, right? And that's at least plausible, sort of. So like as often as the case, probably these official estimates are probably likely to be underestimates. Now, we also try to do some subnational validation. And so here I'm showing data from Colombia. On the left, you have data that was collected by the Colombian government, around sort of May, June 2018, right? And this was based on self-registration. So basically, migrants from Venezuela were asked to sort of please come and register themselves, at certain locations. On the right, you see data from Facebook that was collected around the same point in time, right? And now you see sort of some similarities, but also some differences, right? I mean, for example, on the border, both of these data sources suggest a fairly large number of migrants, but then Facebook data in particular also picks up a larger number further inland, right? And so that's a question, who's wrong, who's right, sort of, right? So in a sense, this on the left is sort of gold standard data, right? This comes from the government itself, but because we were working with people in Colombia during the response, they actually told us, what, this data distribution on the right actually looks more plausible, right? In their own sort of observations, there were, comparable number of people further inland, as were in the border. And their hypothesis was that this official data sort of skewed by the fact that the self-registration efforts were more pronounced closer to the border in terms of sort of advertising, sort of the self-registration campaign, right? And so again, ultimately, we don't know how good Facebook data was in this particular case, but at least people, on the ground told us that it's at least as good as government data, or probably even better. We also generated subnational estimates for other countries where we don't have anything to compare against. But at least this map on the left actually had operational influence, because we picked up a not insignificant number of Venezuelans further south. UNICEF actually adjusted their anti-xenophobia campaign that they were running to not only target the north, but also to target the south. So we were happy that people actually acted on those insights. Now, you can go beyond just estimating the total number of migrants. You can also try to understand the socioeconomic situation by looking at the devices they use. So let me try to explain this graph here. So again, everything is always about Facebook users who lived in Venezuela. So whenever you see a location, is always the host location. These host locations are sorted by the percentage of Facebook users from Venezuela using iOS devices. Okay, so let me try to explain this. So here on the far left, it says Roraima, Brazil. So this is part of Brazil that's in the jungle, that's on the border with Venezuela, right? So this is where typically you walk to, right? The so-called sort of caminantes. Now, in this host location, only 3% of Facebook users from Venezuela, were sort of using iOS devices at the time when we collected the data, right? So it's quite low percentage. At the other end of the scale, you have people who make it all the way to the United States, and among them, actually, the majority, right, sort of 54% use iOS devices, right? So this now induces this sort of order from likely to be poor to sort of likely to be rich. Now, when it comes to sort of this Y estimate, right, so sort of labeled as predicted GDP per capita, we're training a model to predict country level GDP. Okay, so let me try to explain this. Right? So for example, we collect data from the World Bank that tells us the per capita GDP in Argentina. Let's say the per capita GDP in Argentina is $25,000 US. I'm making this up. This is go with this, right? And let's suppose the iOS usage among Facebook users in Argentina is 20%. Right? So now we know, okay, 20% Facebook or iOS use among Facebook maps to sort of $25,000 US. Right? And so now we collect this for all the Latin American countries, so these 15, and then we would fit a single, very simple regression model, right? That just uses a single dependent variable sort of to predict per capita GDP, right? And just using this single variable, you can explain, close to 90% of the variance in per capita GDP. Now, this very, very, very simple model is then applied to all these other cases, right? So this is basically mapping from sort of 3% to maybe $3,000-4,000 US, or from sort of 54% to 58,000 US dollars, right? And so even though we might not be 100% sure about the sort of the actual dollar value, we always observe in our analysis that these three groups emerged. So if we ever tried any sort of modification of the sort of model, right, we always see that Venezuelans in these host countries are probably worst off, and then you have sort of the middle class in a sense, right? So some of these countries are already a bit further away, and then people who make it all the way to Spain or the United States find concern. And again, sort of interesting that you can do this sort of from a distance without any sort of service. And we validated this in other contexts, for example, looking at Syrians in Lebanon, where again, just looking at the iOS usage is actually a strong predictor for relative sort of distribution in wealth. We're happy that this, again, continues to be used through IMAP, who are also sponsored by USAID. And so here's just a shout out to our work. So basically, we sort of taught them how to collect this data. Now, sort of they're collecting it independently. And especially for this audience, I also want to talk about some of the drawbacks and challenges when using this data. It's not okay, great, okay, now we solved the problem of migration data. No, I mean far from it, right? So first, of course, it's a black box. We don't know exactly how it works. But then worse than just the black box is the fact that the black box is not constant across time. So what you're seeing here is a dashboard that we created in particular for UNHCR, where this particular screenshot shows data about Venezuelans living in Brazil, right? And if you just look at this top trend line, you see this sudden dip, right? Like in sort of March 2019 or so, the number actually went down, right? And so it's a question, what's going on, right? Is this now return migration, right? Are Venezuelans returning from Brazil to their home country, or they're moving onwards, right, to Argentina or another sort of country? No, what was actually happening at that point in time is a change in Facebook's algorithm. Okay, so how do we know? Well, we only know because we are collecting this data globally on a roughly sort of 2-weekly basis, and we saw this discontinuity happening globally, right? Like also for people from Germany, in Qatar, and for any sort of combination, right? And there's no reason to believe that in sort of March 2019, the whole world, I don't know, 10% of all migrants globally returned home or something, right? And so, yeah, so first, we were sitting on top of a black box algorithm, but second, this black box is not even stable across time, right? So that's, of course, a big challenge when you sort of analyze this data. So it's an important caveat to keep in mind. Right, so now I want to elaborate a bit on this notion of sort of mapping poverty. I mean, in particular, in the device type, but also other features. This is joint work with UNICEF and a data science company called Thinking Machines, based in the Philippines. The goal of no poverty is one of the 17 Sustainable Development Goals. It's actually the first of those. When it comes to defining poverty, there are different definitions that exist. So the UN typically uses an income-based definition where you would be defined as extremely poor if you're earning less than $1.25 per day. The most recently available data is often quite outdated, right? I already mentioned that it's often tied to censuses that are only done every 10 years. And even then once they're done, they still typically take like a year or two until the data is available, right? And then in terms of data that's available to sort of researchers, often it's not very spatially granular, right? Like ideally you'd like something that's sort of sub-city level so that you can actually target interventions, right? Like if you have something like a poverty reduction intervention, you maybe don't want to target the whole city or certainly not the whole state, but you want to be very, very specific about your intervention. So, okay, how can sort of Facebook advertising data help with this, right? So, well, basically it helps again as a sort of, predictive variable in a, regression task. Ultimately, that's all there is, right? So, yeah, so you get some sort of ground truth that you'd like to predict. In this case, the ground truth comes from USAID's Demographic and Health Survey, DHS. And this survey has data on asset ownership. So they would ask households, basically, how much stuff do you have, right? They would ask, like, do you have a fridge? Do you have running water? Do you have a mobile phone, etc.? Then all those answers are compiled using principal component analysis into a single index called the wealth index, where a large positive number means, the household aggregated into sort of clusters. So like for every location has about sort of 20 households that are being surveyed, and those are then called a cluster. So that's the sort of the target. We'd like to sort of expand the sort of spatial coverage of the surveyed locations, and we'd like to do this using data from Facebook. So in particular, data on Facebook's penetration, right? Just knowing the percentage of users that are on Facebook is, conceptually already, sort of linked to poverty, right? If it's sort of 80% of the population, only 8%, right? You'd expect a difference as well. Of course, the device type is already mentioned, but there's also a type about the connectivity, whether people connect using Wi-Fi or 4G. That's probably also likely to be predicted. And then once you have your sort of, ground truth, and once you have sort of your, sort of predictive variables, then it just becomes a standard regression task, right? You can sort of try your favorite regression model just experimentally for this particular setup. Gradient boosting machines work best, but again, you can sort of, try whatever you're sort of comfortable with. So just to sort of jump right to the results. Okay, so how well does it work, and how much value does Facebook add over other things, right? So what would be another thing to sort of compare against, right? What is a sort of meaningful ground truth? So here, what you see on top is a sort of baseline of content. This is a sort of baseline that uses interpolation from the nearest locations, right? So maybe you're trying to predict a particular location, you don't know the value there, but then you just look at the nearest locations around for which you know the ground truth, right? And then you just average, right? And you sort of, right? And so if all your neighbors are rich, then probably you're rich, right? If all your neighbors are poor, then probably you're poor, right? And this sort of baseline works reasonably well, right? So in the Philippines, it explains about sort of almost half of the variation. This is done in a sort of out of sample setting, right? So it's sort of out of sample variation, almost 50%. Right? In India, there's even more spatial autocorrelation, and this simple baseline would explain almost sort of 2/3 of the spatial variation. So that's sort of like a baseline for which you don't need Facebook, right? Then you compare this with sort of what you get using only Facebook features, including data from Facebook penetration, right? For this, you need to know how many people live in a certain location, right? So you sort of compare the two, right? And those estimates come from, are derived from satellite imagery, not by us, right? We sort of use those estimates for how many people live in a location, and we compare this with how many Facebook users are there to compute the Facebook penetration in that location, right? And these features, beat the sort of baseline in the Philippines, but not in India, right? And then you sort of bring on additional features, for example, population density, as well as a regional indicator, right? So this is like just sort of a dummy variable, right? Maybe the poverty dynamics in Kerala in India are different than they are in Tamil Nadu, right? So you just add a dummy variable, are you in Kerala or are you in Tamil Nadu, right? Or in any other of the states, right? And then if you sort of do this, you're sort of now consistently improving over the baseline. If you go to compare everything, if you combine everything together, you get a bit of further improvement. Just a quick note that the ground truth is actually noisy. So in particular, there's sort of spatial noise deliberately introduced to protect privacy, where DHS does not report the true location. And so we estimate through sort of simulation that no method out there should be able to explain more than about sort of 84% of the variance, right? So 84% sort of like an upper bound, and sort of in India, we're already explaining sort of 73% and maybe 63% in the Philippines, right? Sort of indicating that, using Facebook data as well as sort of, like a strong baseline, you're doing actually quite well in explaining spatial variation poverty. So just mapping poverty, you can also do using satellite imagery. You don't necessarily need satellite imagery, Facebook data. But one of the advantages with Facebook is that you can now do this demographic disaggregation that I hinted at, right? So now we have a model that's trained without demographically disaggregated ground truth, right? We just have a mapping. Okay, if Facebook uses is such and such, then this maps to wealth index such and such. And this model we can now apply, for example, looking only at Facebook users who have a university degree, right? So what is the, what's the iOS usage among Facebook users with a self-declared university degree, right? And this then, sort of lets us create these estimates where here every data point is a location, right? In this case, in India. And we have one prediction for people who have a university degree and one for people who don't have a university degree. Right? And in most locations, in aggregate, we would predict that the wealth index for more educated people is higher than for people who are less educated. And at least, that's maybe obvious, but at least, you get sort of something plausible, which is sort of reassuring. Right? It would be interesting to look at these sort of outliers. Again, we don't have ground truth for those, but it would be maybe interesting to look at, is it really true that here people, without a university degree have higher wealth? Maybe, right? Or is this just sort of noise in the model? But at least the overall pattern is sort of plausible, which is sort of, reassuring that you can sort of do this disaggregation. Now we try to do the same with sort of gender disaggregation, right? Where we have this model that's sort of, again, trained in a sort of demographically disaggregated manner, but we apply it to sort of different demographic subgroups, right? And so now, again, every location is a location, every data point here is a location in India. And so we make one prediction for the wealth index for women and one for the wealth index of men, right? Now you see something that's surprising, at least in the Indian context, right? Sort of surprisingly gender equal. Right? That's a bit weird, right? And this is now not even plausible, right? Sort of so this is right. So why am I saying this so confidently? Well, for example, if you look at data from the Global Gender Gap Index, so this is a report that the World Economic Forum puts out, it ranks India in terms of gender equality for economic participation and opportunity, 149 out of 153 countries included, right? So India is far from being gender equal. So this is not plausible. So what's going on here, right? So why is our model sort of fooled? And so what's going on here is the so-called Jackie Robinson effect, right? So it's a particular type of survivorship bias. So Jackie Robinson was the first African-American to play in the Major League Baseball in the US. And for him to make it, despite all the systematic racism, he had to be exceptional. Right? So if you look at his batting averages, he was one of the all-time greats of baseball. Now, if you only look at him and then extrapolate out to all African Americans, right? You think all African Americans must be, exceptional at baseball, right? Because those are the only ones you see, right? They need to be, otherwise you wouldn't even see them, right? And that's the same thing that's happening here on Facebook, right? So there are very few women on Facebook in India compared to men. But those women who are on Facebook are exceptional, right? In the sense that they are more likely to have iOS devices, they're also more likely to have university degrees, et cetera, right? And so if you then extrapolate out from this sort of very biased subset, you come to this conclusion that, well, women must be doing extremely well in India because those are the only ones I can see, right? And so this is now exactly the wrong conclusion. So what can you do about this? Well, you can now sort of limit the features that you use in your model. So for example, here, I'm showing now a prediction for a model that does not include the device type, right? Like, for example, iOS, but that solely uses the Facebook penetration. Right? So what's the percentage of either men or women who are sort of using Facebook? And only based on that feature is making a prediction for the wealth index. So this model overall performs worse than the more complex model, right? In the aggregate setting, but now it's likely to be less biased once you sort of disaggregate by gender, right? And so now at least you get something that's sort of plausible in terms of the patterns that you observe, where now for every location we predict that men are doing better than women. Again, we're happy that this sort of work continues to be operationally used by this company that I mentioned, Thinking Machines, who have also expanded it with additional features, such as features derived from OpenStreetMap. The last example, and okay, I'll just keep an eye on time, I want to mention is this notion of digital gender gaps, so to elaborate a bit on this. This is joint work with an NGO called Data2X, as well as the University of Oxford. And so here, just quickly sort of to motivate why we're interested in using advertising data to study digital gender gaps. So by now, about 4.7 billion people on the planet have internet access, right? So this is actually the majority of the world's population, about sort of 60% of the world's population. But this access is not distributed equally, right? So for example, in Niger, for every 1 woman with internet access, you have 3 men with internet access. Or in Iraq, it's roughly sort of 1 to 2. But in a sense, both Niger and Iraq are positive cases, right? Because these countries collect this data and they report this data, right? So actually, for most countries, we don't have this data. So let me show you. Show you in a second a map where you can sort of see this. So to address these data gaps, we create this platform called Digital Gender Gaps. It's also publicly accessible, where you can sort of see what I'm showing you next. So here, I'm showing you data from the ITU. This is the International Telecommunication Union, is one of the UN agencies. And what I'm showing you here is data on the female to male ratio of internet users. And so a value of 1.0 or larger means that women are at least as likely as men to have access to the internet. Okay, and you sort of see in most of Western Europe and USA have at least in terms of internet access, have more or less achieved gender equality, right? But other countries have not, right? So for example, here's the example of Iraq that I was showing you before. But now you also see a lot of countries don't have this data or don't report it, right? So for example, for India, there is no data available, right? So now we are using data from Facebook, use these countries here as sort of, training data as ground truth to then make predictions for the other countries. Okay, so what you're now looking at here, this is now no longer ground truth, but this is a model output of a model that uses only online features, right? It uses solely data from Facebook to make these predictions, right? And now using this data, we would predict that in India, it's roughly 2 to 3. So for every sort of 2 women with internet access, you have 3 men with internet access. So how does this work and how well does it work? So here showing you disaggregation or comparison of different models. So here on the left, you have a model that apart from a sort of constant or like a model intercept has only one variable to make the prediction, right? This is the Facebook gender gap. This is just the ratio of female to male Facebook users, right? That's all there is. And using only this variable and this sort of constant, you can explain or in terms of model fit, right? You fit almost sort of 70% of the variance across countries, right? So just using a single variable. Now you can compare this with a sort of more traditional econometric model that potentially could use a lot of variables. In this particular case, after sort of feature selection, picks up features related to internet penetration and the global data from the global gender gap report on, for example, higher education. And using all these sort of features together, it only explains slightly less, sort of 61% of the variance. And then if you combine the two, right, you kind of get the best of both worlds. So you have a very, very nicely fitting model. But now you're sort of relying on 2 data sources being available. So that means that you can't make quite as many predictions. All right, so we're happy that this data is also operationalized and sort of being shared through this SDGs Today portal. Now, I also want to talk a bit about the sort of the recency that of this data and what you can sort of do with this. It's difficult to do through other sources, right? So this I'll explain this in the context of Afghanistan. Right? I'm sure you're familiar, with what's going on in Afghanistan, or sort of last August. Kabul fell again in the hands of the Taliban, right? And so now it's a question: what does this mean for internet access, broadly speaking, but also what does it mean for women in particular, right? Like sort of, for example, will women still have access to the internet? Will they still have access to social media? How are they using it, right? And so there are some sort of conflicting stories, right? So when people say, okay, now people are no longer on social media, but then there are also sort of these sort of social media campaigns run by women, right? So it's part of sort of like their empowerment. So what I'm showing you here is now data we've been collecting from Facebook over time for the daily active users. Right? So earlier I showed that mentioned that there's sort of data on monthly active users, and everything else so far was derived from monthly active users that are more stable across time. But this particular plot is now derived from the daily active users, right? That sort of fluctuate more. And here in black, you see the daily active users for all of Afghanistan for adolescent girls aged 15 to 19. Right? So this is this line in black. Right, and you could sort of see it was sort of decaying in 2018, right? So as I think overall Facebook is using market share to Snapchat and TikTok and other platforms, and then it sort of stabilized, right, in sort of 2020, and then interestingly it actually went up, right? So here this line sort of marked D is the date of the fall of Kabul. This peak here is when there was this social media campaign, "Do not touch my clothes," run by Afghani women, sort of on social media. And since then it has come down a bit, but the number of young women on Facebook is still at levels not seen in many years, right? So which is interesting, right? It's not necessarily what we were expecting. So on black is the raw number, and then sort of this sort of turquoise greenish sort of color, you have the female to male ratio. So not only are there now more women or young girls on Facebook than there were before, but they're also making up a bigger percentage of the total pie compared to sort of boys in the age range. Right. So this is now an interesting observation, and again, where it's sort of hard to do this sort of analysis using other data sources. About to wrap up, so just quickly also on the subnational aspect. So everything I showed so far was sort of national. What we're doing now, subnational work, starting with Africa in particular. Okay, so then to wrap up. So what is some of the strength, right? So I mean, I mostly spoke about Facebook, a tiny bit about LinkedIn at the beginning, but you can get similar data also from Weibo, Snapchat, and Google. And again, you get all of this data free of charge. And in almost all cases, there's an API, so you can very, very easily automate sort of data collection. You get relatively real-time data. It's not necessarily real-time as of this hour, but for the daily active users, we think that there's a lag of about a week or so, right? So the data you collect now sort of reflects usage from maybe like a week ago. It's anonymous and aggregate, so I don't think privacy, or at least individual level privacy, is the biggest concern. There are other concerns, but I don't think this is the biggest one. There are a lot of different targeting attributes, right? And you can collect this data sort of free of charge. Now, some of the drawbacks, right? So first, it's a black box. So we don't know exactly how Facebook infers some of these attributes, right? And this black box can also change over time. Of course, this data is highly non-representative, right? I showed this sort of Jackie Robinson example, right? Where now in India, you only have the rich, well-educated women on the platform. I mean, not only, but they're overrepresented, right? And so then, it's a challenge. How do you, what sort of generalizable conclusions can you draw from that? Facebook, as sadly all of the other platforms, has a sort of gender dichotomy, right? It only supports either male or female for advertising, but clearly that does not reflect the reality of everybody. Usage patterns, of course, change over time, right? So if you now have a sort of long-running system, right, over many years, so I saw that in Afghanistan, for example, right? So the Facebook users sort of changes, right? And so maybe then that leads to some sort of conclusions, in your model about the offline world, but that's actually not driven by sort of offline world economic sort of changes. It's just driven by how Facebook is used and by whom. Another big limitation is there's no historic data available. Right? So if you wanted to have data, oh, that's great. Now tell me how many Facebook users were in my country or in my city before COVID-19. I cannot. Right? I mean, we've collected some data, over the past year. So if it's country level data, maybe I can help. But if it's something more specific, you have to sort of start collecting data today, so that 3 years from now you have data that goes back 3 years. And last but not least, there's a risk of misuse, right? So because ultimately you can identify vulnerable populations, not individuals, right? But for example, I showed you where the Nepali are in Doha, right? Maybe that's not super sensitive, right? But maybe other migrant groups and other settings, right, are sort of sensitive, right, and are at risk of sort of persecution, right? Or maybe people with certain interests, right, like sort of, so maybe even interest related to religion or sort of, well, you could sort of see how there are certain risks. And last thing, not related to Facebook, but just sort of to the sort of line of work, right? we're doing this work, right? Hopefully, creating better data, and that will then lead to better decisions, right? That's sort of the usual motivation, right? But of course, that's not always the case, right? I mean, for example, global warming, there was an obvious example where we've had good data for, decades, and still we're not acting, right? So hopefully still, by collecting, better data, including data from, advertising platforms that are more recent, more spatially fine-grained and more demographically disaggregated, we can at least highlight certain issues, right, related to sort of migration and poverty and gender gaps. But of course, just collecting data will not fix those issues. So yeah, thank you very much, and hopefully there's still some time for questions.
Thank you very much. Thank you very much. This was really amazing. I mean, it was amazing in the sense that we always see when we use Facebook for advertisement, we always see those numbers to the side, on the side of the screen. But just thinking about how they can be used, how many things can be done with those numbers was amazing seeing them. Also, thank you very much for discussing all the shortcomings or all the problems that we can face with as we try to use those numbers in our own research. In that sense, also, I think your presentation has done a very good job in showing limitations or the problems that we need to deal with. There are very good questions, mostly about the way we can apply this to our research, and I will just read them to you, and let's see your responses. So first of all, I think you have already responded to this one, but can you just, again, I will ask again. Zaza asks whether it is possible to retrospectively access data via the IPAs.
No, unfortunately not. So again, if it's country level data, get in touch, and maybe we have an archive, but unfortunately it's only, right, you're launching an ad campaign today. So, as of today, those are the numbers. There's no historic archive available.
Okay, a relative question about the API. So Sean asks, how does one access the API and obtain the raw data?
Yeah, so I will, so as with most APIs, right, you have to sort of create like an access token, sort of, and then once you have that access token, it's a simple what HTTP GET request, right? There's a particular URL, like graph.facebook.com/something/delivery estimate. You provide your access token, some parameters of what you want to collect, and then you make that request. It's just like requesting a website, and what's returned is not HTML, but it's sort of a JSON that has, that I was sort of showing before, that has a lot of information, including this monthly active users and the daily active users. And so, yeah, so the slide deck has a link to like a sort of tutorial that explains how you create an access token, and then how you can sort of automate that. So I would start there, and yeah.
Yeah, thank you. A related question about the APIs. Frederick asks whether you have any experience on how prone the API is to sudden changes in structure and access, i.e. how stable it is to work with.
Yeah, so in terms of structure or using, we have not had a lot of problems. So once in a while there's a new API version, but it sort of usually there's a pretty good sort of backwards compatibility, and there's plenty of time to sort of to adjust your code. These sort of temporal changes that I mentioned mostly relate to, I think, sort of, let's say, more of these sort of derived features. So we have not seen dramatic changes from one day to the next, let's say, in terms of number of female Facebook users in India, sort of. So that number is fairly stable, and of course might follow some, some trend, right? Maybe Facebook is using market share or not, or something or so that you could sort of see through this data, but otherwise it's fairly stable. When it comes to, I mean, I mentioned this case of, a migration background or where somebody lived. So there we once in a while see changes, not more than once a year. So we've seen it, I think in March 2019, and then I think again in March 2020, but not in March 2021, sort of a social. So meaning once in a while, like maybe once a year, you have sort of changes. For the interests, right? If you're interested in how many people are, I don't know, interested in math and science, how many girls versus boys or something, or sort of or so. The interest seemed to be very unstable, to be honest. So like every couple of weeks, if not months, you would get, like a new estimate, and in some cases dramatically different. So when before the first Donald Trump election, in 2016, we were collecting data on how many people are interested in Donald Trump versus Hillary Clinton, and there we would every week observe vast, factor 3, 4, up, down, sort of stuff, without anything happening in the real world. It's not that there was like every week there was like a TV campaign or something, right? And even then, like a factor 4, doesn't really make sense, right? Like sort of, how is that possible, right? And so so the interest seemed to be far less stable. But just the sort of the basic demographics, right? Like how many young women with an iOS device, it seems very stable, and we don't have any evidence that Facebook would change its algorithm, its algorithms in quotes.
Thank you very much. So another question from Zaza: what routine do you suggest for long-term data mining, and how do you deal with variations in the time of day? Could you identify any patterns here?
Yeah. So for time of day, for most of our projects, we use these so-called monthly active users rather than the daily active users. And these monthly active users are fairly stable. I mean, they certainly don't change hour to hour, even day to day. I think they change maybe like every other week or so. So they are fairly stable. You don't have to worry about sort of monthly fluctuation. The daily active users, they do change from hour to hour. So then it depends, right? You'd have to sort of do some sort of probably some averaging, right? So for example, I didn't mention this before, but the data for Afghanistan that I showed is actually sort of like a 7-day sort of average. It's not just for the single day sort of so on. Even if you do this, right, even if you average 7 days, you still see a lot of variation sort of or so, but that variation seems to be sort of real in a sense. Yeah, so for the hourly thing, I think, it's I don't know, maybe it's a feature. You'd have to sort of look at it in context, whether you want to look at it, but I don't know. I don't have much to comment on that. What was the other thing? I think I missed part of the question. Was there another part of the question?
How do you deal with variations of time? Could you identify any patterns here regarding routines for data mining?
No, not really. I mean, the patterns that are there seem to be real, right? I mean, in the sense that, for example, women joining the platform or leaving the platform, or market shares growing or shrinking, right? But those are sort of not hour to hour patterns, right? This is sort of like more long-term patterns, but definitely you have to correct for, right? Like in particular, if you are studying sort of youth, then sort of I think the youth are more and more abandoning Facebook, right? So you have to be very aware of this. Maybe one of the things I should have emphasized more, right? I mean, for in particular for youth, maybe Instagram is more interesting, but Instagram is part of the same platform, right? Like sort of so yeah. Here, just with a very trivial API change, you can collect data on just Instagram, for example.
There is a question about Sean asking about terms of service. He says that terms of service for developers' accounts prohibits making platform data available to a search engine or directory without our prior express written consent. And he asks, does this prohibit us from publishing a data set derived from this data as many journals require for publication?
Yeah, that's a good question. So first, I think, at least as far as I remember, those terms of service apply to after actually launching the ad campaign. So I'm not 100% sure if they apply to the data before launching the campaign, right? Because I think that they refer to data derived from running the campaign, right? Because we never actually run a campaign, So that's the first sort of. I'm not sure if it applies. Having said that, like we typically refrain from publishing raw data, but for example, derived data, right? So for example, like, on this platform, digitalgendergaps.org, you can download the female to male ratio of Facebook users, right? And that might already be enough, right? And sort of so on. There, I think I have less concerns. But I also want to mention one example, sort of. So we were working with IMAP, again, related to an NGO, based in Colombia, looking at sort of the Venezuelan migration, and they published raw numbers on how many Venezuelans were living in certain parts, sort of. So through what's called the Humanitarian Data Exchange. So there's a platform run by UN OCHA. And well, make a long story short, Facebook did not like that, right? Right. So basically, they eventually contacted the platform that was hosting this. In this case, it's operated by the United Nations, to take down this this data, right? Right. But in that case, I think it was not so. I mean, not necessarily. I mean, short terms of service kind of, but also it's just on top of this. It's a very sensitive issue, right? Like if you migration is a very politically charged issue. So I think you don't want to just naively publish data on this, because people might also not necessarily interpret it appropriately, right? And so it's not a crisp answer, but just be mindful. I'm not going to say do it, don't do it, but just be mindful of also the application domain.
Thank you very much. There is one last question that I want to ask before ending the session, as we are now, we have already run out of time. So Frederick asks, I mean, you have already talked about the bias issues. So the question is about that. I would expect that there are some issues with bias. In Germany, for example, we would underestimate teenagers. In other countries, people in areas without internet access. Do you have any experience with incorporating this, or know of any work quantifying this bias?
Yeah, very good question. So it's tricky, right? Of course, you can try to do some, post certification, whatever, but of course, ultimately, if in India you only have rich women on the platform, then okay, how can you generalize from that, right? Like so that is hard to deal with. Right? But in some of our other work, we for example, for our work on gender gaps, we typically look at how many women are on the platform versus how many men are on the platform, right? So in that sense, the bias is the signal, right? Like if we see that women are missing from the platform, then that becomes ours, the signal itself, right? So there we have to worry about less, right? But yeah, in other instances, I don't have a simple solution, right? So sometimes it's okay to look at just relative trends, right? Like if you have more in this area than in that area, maybe those conclusions are robust against certain types of bias, right? Or if things are going up or down, again, those simpler conclusions might be robust against certain biases, or at least by looking at, for example, device types, you can sometimes get a sense of what's going on, right? If what you're studying correlates highly with device type, right, that at least you need to be aware of, okay, maybe there's something to worry about, right? If the Facebook penetration is, not even and if might be oversampling, richer people, but yeah, I don't think there's a one size fits all answer to how to deal with bias in social media.
Yeah, thank you very much for the answer. Now Anya will also join us. I will stop recording, Anya, or do you want to continue before I stop it?
No, let's just to thank Ingmar for his fantastic talk and all the exciting research that you shared with us, and just showing us the possibilities of what to do with this data. It was really fascinating. This concludes our little spring series that we had in the past week with the 3 sessions. I do see that some people, did join us for the 3 sessions. So thank you very much for tuning in live. But as I already said in the chat, we are recording these sessions and we'll make them available on our YouTube channel. Once all the slides and video links are also uploaded to our website, we will let you know through our newsletter. And finally, I wanted to kind of invite anyone who is interested in this research, who's doing exciting research, to share, because we want to keep the webinar series going. I think it's a fantastic resource for people working in this field or trying to kind of get ideas, and so we hope to get more people to also participate in sharing their experiences. So if you have something that you think you want to put together as a session, similar to what Ingmar did today, or other sessions we ran, please do get in touch with us, and we will have another series probably October, November time. So stay tuned, and thanks everyone for participating. Great questions again. And of course, special thanks to Ingmar for a really fascinating talk. So yeah, thank you everyone.
Thank you very much, Ingmar. Thank you,
Thanks.
everyone.
Bye.